A very good morning, dear students. In this video I am going to explain about one of the chemical property of aldehydes and ketones. So in last class we have seen about the first chemical property, that is nucleophilic addition reaction. So to this nucleophilic addition reaction, aldehydes are more reactive than ketones. So due to two important reasons, that is steric hindrance and electronic effects. Now I am giving one of the example related to that nucleophilic addition reaction. Okay, so in last classes we have seen about addition of hydrogen cyanide, addition of sodium hypohalide, sodium hyposulfide or sodium bisulfide, and next one addition of alcohols and addition of Grignard reagent. Okay, now in this session we will see about addition of ammonia and its derivatives. So ammonia is a compound which is containing NH3 as the formula. Okay, so this is the structure of ammonia. See, here the central atom is nitrogen. Nitrogen is attached with 3 hydrogen atoms. Okay, if any one hydrogen or more than one hydrogen or nitrogen is replaced by some other atom, then that is said to be derivative of ammonia. Okay, now these aldehydes and ketones, generally we can represent them by using C double bond O. They can easily undergo reaction with that ammonia and its derivatives, can give different types of products. Again it comes under nucleophilic nucleophilic addition reaction. Now we will see how these ammonia and its derivatives undergoing reaction with carbonyl compounds. See here, when aldehydes and ketones reacts with ammonia and its derivatives, they leads to give this kind of compound. That means here between carbon and nitrogen a double bond is created. Such kind of product is obtained when carbonyl compounds react with ammonia and its derivatives. For example, here I have taken the general representation of carbonyl compound, that is C double bond O. When it react with NH2Z, here Z is nothing but in place of hydrogen if any group is substituted, or Z may also contains hydrogen. If in the place of Z hydrogen is present, then that is said to be ammonia. In place of Z, if any other atom is present other than hydrogen, that is known as derivative of ammonia. When this kind of group react with carbonyl compound, first what happens? Pi bond present between carbon and oxygen moves towards oxygen atom. Then oxygen gets negative charge, carbon gets positive charge. Okay, from these two hydrogen atoms, one hydrogen is added to oxygen. One hydrogen is added to oxygen, converts into COH. Now remaining part is NHZ. That NHZ is added to carbon and we will get this compound. So which is nothing but tetrahedral. Planar structure of carbonyl compound changed to tetrahedral intermediate complex. So which again on removal of water, that is H2O is released. OH from here and hydrogen from nitrogen together eliminates as H2O. Then what happens? Carbon is losing one bond, nitrogen is losing one bond, between them a double bond is created, then we will get C double bond NZ. Okay, this compound is obtained. Now we will see the reactions one by one. Okay, so first, if it reacts with ammonia, reaction with ammonia. Okay, I am taking here general representation of this carbonyl compound, that is R C H double bond O or R C double bond O H. When this carbonyl compound react with ammonia NH3, for our convenience I am separating this hydrogen. Okay, in the first step what happens? Pi bond moves to oxygen, oxygen gets negative charge, carbon gets positive charge. From here hydrogen eliminates as H plus, added to oxygen. NH2 minus is added to carbon. Then we will get, first write R, C, H already present. Now double bond became single bond and to that OH is added. Okay, now to the carbon this NH2 part is added. Now we got this intermediate. So this intermediate involves in losing of water. Okay, so water can be lost from this compound. OH from this carbon atom, hydrogen, one of the hydrogen, two hydrogens are present. One hydrogen on nitrogen reacts with this OH, eliminates as H2O. Then what happens? Carbon is losing one bond, nitrogen is losing one bond. Between them double bond is created. We will get here R, C, H, double bond. Okay, this double bond I am writing here. Double bond, N, bond, H. That's it. A compound is obtained. This is known as imine. Imine. Okay, that is about the reaction with ammonia. When carbonyl compounds react with ammonia, it can give imine as the final product. Okay, next, second question, second derivative is with amines. With amine. What is amine? If in the place of one of the hydrogen, okay, R group is replaced, then that is known as amine. If two hydrogens are replaced by two R groups, that is secondary amine. If three hydrogens are replaced by three alkyl groups, that is known as tertiary amine. If only one hydrogen is replaced by R group, that is known as primary amine. Okay, now reaction with amine. Amine is one of the derivative of ammonia. I am taking here general representation of aldehydes and ketones, or C double bond O H. When it reacts with amine, that is R, N, H2. That H2 I am writing separately as N bond H bond H. When these two undergo reaction, what happens? Pi bond initially moves here, oxygen again getting negative charge, carbon gets positive charge. From here hydrogen eliminates as H plus and added to oxygen, and NHR part is added to carbon. First write this. Okay, R, C. Now on carbon hydrogen is present, double bond is converted to single bond. To this single bonded oxygen hydrogen is added, and to the positively charged carbon NHR is added. NHR. Okay. Now in the next step what happens? Removal of water. OH from the carbon atom, hydrogen from the nitrogen eliminates as H2O. Then between carbon and nitrogen double bond is created. So then we will get here R, C, H. Now between carbon and nitrogen double bond N. To this N, R group is attached. Okay, then it is known as substituted imine. Okay, it is known as substituted imine is obtained. Because in place of hydrogen alkyl group is substituted, we can call it as substituted imine. Okay, it is also known as Schiff's base. Okay, that is about second reaction. Now we will see the third one. That is with hydroxylamine. Reaction with hydroxyl amine. First we will see what is hydroxylamine. In ammonia, okay, I am writing here ammonia structure once again. NH3. In ammonia, if one of the hydrogen is replaced by OH group, if one of the hydrogen is replaced by OH group, then we will get which structure? NH2OH. NH2OH. This is called hydroxyl amine. Hydroxyl amine, which is one of the derivative of ammonia. When that hydroxyl amine reacts with the carbonyl compounds R, C double bond O H plus NH2OH. Okay, and on that N, OH is present and two hydrogens are also present that I have written separately. Now when these two undergo reaction, first step same as it is what happened in the above two steps. Okay, between carbon and oxygen, pi bond moves to oxygen, oxygen gets negative charge, carbon gets positive charge. And from here hydrogen eliminates as H plus added to oxygen, NHOH part is added to carbon. Then we will get here R, C, H. Okay, now double bond became single bond. To that oxygen, this hydrogen is added, and to the carbon atom, NHOH group is added. NHOH. Okay, in the next step, removal of water as usual what happened in the above two steps. Okay, see here hydrogen from the nitrogen atom, OH from the carbonyl carbon atom together eliminates as H2O. Now between carbon and nitrogen double bond is created. We will get here R, C, H double bond. Okay, here whatever is there that I am writing this side, double bond N, and to that nitrogen OH is present. Okay, this is known as oxime. Oxime. If it is found by ketone, that is known as ketoxime. If it is found by aldehyde, that is known as aldoxime. Okay, so that means when hydroxylamine reacts with carbonyl compound, it can be converted into oximes. Remember, when carbonyl compound or aldehyde and ketone reacts with hydroxyl amine, finally it leads to give oxime as the final product. In place of carbonyl compound, if you take aldehyde, that gives aldoxime. If you take ketone, that gives ketoxime. Now we'll see the fourth derivative, that is with hydrazine. Now we'll see how this hydrazine is formed. If suppose in this ammonia, okay, in this ammonia, if one of the hydrogen is replaced by NH2, not this one now, if one of the hydrogen is replaced by NH2, then that converts into NH2, already two hydrogens are present, now one more NH2 is added. This is known as hydrazine. Okay, if in case of ammonia, if one of the hydrogen is replaced by NH2 group, that is known as hydrazine. Now we'll see the reaction with hydrazine. Now the reaction with hydrazine, fourth one, with hydrazine. We know the structure of hydrazine, that is NH2 bond NH2. Okay, when carbonyl compounds reacts with hydrazine, I am writing carbonyl compound general representation, that is RC double bond O, either H or R. Okay, when it reacts with hydrazine, that is NH2 bond NH2. Okay, this NH2 I am writing separately, that is writing two bonds separately with the hydrogen atom. When these two undergo reaction, first it gives an addition product. So initially the pi bond present between carbon and oxygen moves to oxygen. Oxygen gets negative charge, carbon gets positive charge. From here hydrogen eliminates as H plus and added to oxygen, and remaining NH2 part will be getting negative charge, that is added to carbon atom. Then we will get the first product, that is RCO. R. In place of R, either hydrogen present or alkyl group. If hydrogen is present, that is aldehyde. If alkyl group is present, that is called ketone. Now to this oxygen, hydrogen is added. Now to the carbon atom, NH2 is added. NH2. We should not add this nitrogen because its valency is balanced, but this is losing one bond, so we have to add this NH part to the carbon atom. When it involves in dehydration, that is removal of water, OH from the carbon, hydrogen from the nitrogen, only we have to remove this hydrogen, because between this carbon and nitrogen we should make a pi bond, so that we have to remove hydrogen from this nitrogen which is attached to carbonyl carbon. Now these two together eliminates us H2O. Then we will get the final product RCR. Okay, double bond. Okay, double bond N, and to that N, NH2 is added. Okay, this is called hydrazone. Hydrazone. Okay, when carbonyl compound reacts with hydrazine, it can be converted into hydrazone. Okay, that is with reaction hydrazine. Now the next reaction is with phenyl hydrazine. We'll see what is phenyl hydrazine. If suppose on ammonia, okay, this is ammonia. On this ammonia, if one of the hydrogen is replaced by NH2 NHC6H5, NH2 NHC6H5, phenyl hydrazine. Okay, this is called phenyl hydrazine. Understand? That means, okay, this is as it is. Now one of the hydrogen is replaced by NHC6H5. It leads to give a compound, that is on this nitrogen two hydrogens are present, that I have written here, and bond NHC6H5. Okay, this is called phenyl hydrazine. If NH2 bond NH2 is present, that is called hydrazine. On this hydrazine, if one of the hydrogen is replaced by C6H5, that is known as phenyl hydrazine. Okay. Now this phenyl hydrazine reacts with carbonyl compound. The next reaction, okay, fifth reaction of carbonyl compound is with phenyl hydrazine. Phenyl hydrazine. I am taking general representation of carbonyl compound. Now, R, C, double bond for R. Here it may contain hydrogen or alkyl group, that depends on aldehyde and ketone. Now it reacts with phenyl hydrazine, that is NH2, NH, C6H5. Okay. First what happens? Pi bond. As usual, pi bond moves to oxygen. Oxygen gets negative charge, carbon gets positive charge. From here, hydrogen eliminates as H plus, that is added to oxygen. So this hydrogen is added to oxygen and remaining NH, C6H5 is added to carbon. Then we will get an addition product. First write this one. R, C, and here one R is present. Here OH is present. Now to the carbon, NH, C6H5 is added. NH, C6H5 is added. Now this addition product involves in removal of water, that is dehydration. OH from the carbon atom, hydrogen from the nitrogen eliminates as H2O. Remember, we should not remove hydrogen from here because this nitrogen do not attach with carbon. Only this nitrogen is attached to carbon. So hydrogen from this nitrogen, OH from the carbon eliminates as H2O. Then we will get here R, C, R, double bond, N, NH, C6H5. Okay, this is called phenyl hydrozone. Phenyl hydrozone. That means when carbonyl compound reacts with phenyl hydrazine, it gives phenyl hydrozone. Remember, all these compounds are very important for 1 mark. From this reaction of ammonia and its derivative, compulsory 1 mark question will be asked. Okay, when carbonyl compounds reacts with phenyl hydrazine, it can be converted into phenyl hydrozone. Understand? Now we'll see the next one. Last reaction under this reaction with ammonia and its derivative is the sixth one, that is reaction with semi-carbazide. With semi-carbazide or semi-carbazide. Okay, so semi-carbazide is nothing but semi-carbazide is nothing but NH2, NHCO, NH2. Okay, see here, when carbonyl compound reacts with NH2, NHCO, NH2. What happens on this ammonia? One of the hydrogen is replaced by NHCO, NH2. That is known as semi-carbazide. When it reacts with this, what happens? Pi bond from here moves to oxygen. Oxygen gets negative charge. Carbon gets positive charge. From this nitrogen, hydrogen eliminates as H plus, added to oxygen, and remaining part is added to carbon atom. Then we will get here an addition product, that is R, C, R. Now oxygen is attached with hydrogen. Now to the carbon atom, NH, CO, NH2 is added. In the next step, removal of water should take place. From carbon, OH, from nitrogen, hydrogen. Okay, when these two eliminates as H2O. Now, one valency is less on carbon and one valency is less on nitrogen. Between them double bond is created. Then we will get RCR, double bond here. No hydroxy, that is eliminated. Double bond N, to that N, NHCO, NH2 is added. This is called semi-carbazone. Okay, it is called semi-carbazone. That means when semi-carbazide reacts with carbonyl compound, it can be converted into semi-carbazone. Okay, so that is about the sixth reaction. And last one more is there that I will explain now. Last reaction is with 2,4-dinitrophenyl hydrazine. I'll write the structure. First write down general representation of carbonyl compound. When it reacts with NH2, NH, C6H5. On C6H5, if at second and fourth position, so this is the substituent, adjacent position is second. This is first, second position NO2, third and fourth. Okay, at fourth position NO2 is present, so we can call it as 2, 4. This is first, second, third, fourth. At second and third, fourth positions NO2 are present. 2,4-dinitrophenyl, and this is hydrazine. Okay, then it is called 2,4-dinitrophenyl hydrazine. Okay, when it reacts with carbonyl compound, you just try to write the product. This is homework for you. Okay, you just try to write the answer and send me your answer to my number. Okay, so when carbonyl compound react with 2,4-dinitrophenyl hydrazine, same reaction will take place. So initially pi bond moves to oxygen gets negative charge, thereby hydrogen from here is added to oxygen, remaining part is added to carbon. Okay, so then addition product involves in dehydration. Finally we will get 2,4-dinitrophenyl hydrazone. You try to write this reaction and find out the final product. And finally we will see the overall reactions of addition of ammonia and its derivatives. When ammonia reacts, what we will get? Amine. When amine reacts with carbonyl compound, we will get substituted amine. With hydroxylamine, it gives oxime. If suppose hydrazine reacts with carbonyl compound, we will get hydrazone. When phenyl hydrazine reacts, we will get phenyl hydrozone. Semi-carbazide on reaction with carbonyl compound can give semi-carbazone. The overall reaction chart will be this one. See, in ammonia, hydrogen reacts. This is the part which is reacting with carbonyl compound, and we will get this one. This is known as amine. When amine, so that means here ammonia, one hydrogen is replaced by R group. So then we will get this kind of compound which is known as substituted amine. When hydroxyl amine with OH on NH2 reacts with carbonyl compound, we will get oxime. Okay, so if hydrazine reacts, we will get hydrazone. Phenyl hydrazine reacts, we will get phenyl hydrozone. 2,4-dinitrophenyl hydrazine reacts, we will get 2,4-dinitrophenyl hydrazone. Finally, carbazide on reaction with carbonyl compound can give this kind of compound known as semi-carbazone. If you want, you can take a screenshot of this chart. It will be helpful for you. So this is about the reaction or addition of ammonia and its derivative. With this, first chemical property is completed, that is nucleophilic addition reactions.